today we're going to talk about something about a function, which is range. And we usually, when we talk about a function, we would look at the domain, the range, and the function itself, the relationship itself. So domain, we already learned that is what the x value can be, and the range is what the y value can be, or what is the range of all the output of the function. So let me give you two examples. We can find the domain and the range. First function is f of x equals ln x plus 1. All right, so for this one, what is the domain? Well, if you remember, the graph of the function looks like this. This is y equals ln x, right? This is the graph of the parent function. And then if you have x plus 1 here, you're going to shift this curve to the left horizontally by 1 unit. So that will be from here and to here, right? So this is the vertical asymptote, and just like here, the vertical asymptote is the y-axis, and that's this function, and this one is -1, 0. So the new function, this one is ln x plus 1. So we did a little bit of review about the function transformation. Therefore, from this graph, we can tell very clearly our domain is what x value can be. That x can be from -1 and above. It cannot be -1. So -1 parenthesis is in the positive infinity. And the range is what y value can be, and you can tell that's from negative infinity to positive infinity. So this is very simple. This is the first one. The second one, g of x, let me do that, is 9 minus x squared. So it's a quadratic, and from 9 minus x squared, we know it is a open down. If you have if you remember the parent function, and this is y equals x squared, right? And then flip it down like that. Then this is y equals negative x squared, and then you're going to shift up by 9 unit. So that would be your, sorry, not very accurate, but you got the idea. And here's a 3 and a -3, and here's a 0. So that's why. So this is a graph of this function, of this 9 minus x squared. Therefore, you can see the domain is, because there's no denominator, there's no log, there's no square root, so we don't need to worry about that. So the domain is negative infinity to positive infinity. X can be any real number, and the range is what the y value can be. You can see the y is everything from 9 and down, but it could be 9 because it will pass through this point. So the range will be from negative infinity to positive 9, and the bracket, because that's inclusive, it could be 9. All right, so this is fairly simple. If I give you a simple function, then you can just use your if you can remember the graph, that'll be better. If not, then you can just use what we learned earlier about the definition of each functions. So you can find the range and domain. Now let me ask you a new one. So find the range of f of g of x, where f of x equals ln x plus 1, and the g of x, just like we had earlier, is 9 of x squared. So we are looking for the range of this composite function. Then let's write it first. F of g of x. F of g of x. G of x is here. So I just replace that. So I have f of 9 minus x squared. All right, now f of something, f of x, which is ln that independent variable plus 1. So therefore that will be, and then 9 minus x squared, that to replace this x, then plus 1. So which is ln 10 minus x squared. All right, so we need to find out what is the range of this function. How do we do that? How shall we do that? First of all, we know that for the ln 10 minus x squared, this part, 10 minus x squared, has to be greater than 0, right? Has to be greater than 0. And therefore, if this is the case, then we move this negative x squared to the right side, or you can say plus x squared on both sides, because someone preferred to do that, which is totally fine. And then you get x squared less than 10. So x squared less than 10. Therefore, x will be less than square root of 10 and greater than negative square root of 10. So that's our domain. We know this. What about the range? If you think about this log function, it's an increasing function, right? So when inside part 10 minus x squared, when 10 minus x squared is greater than 0, but if you remember that x squared is always greater than 0, right? Greater than or equal to 0. So negative x squared would be less than or equal to 0. Would you agree? Right? You multiply by a negative number, and then you plus 10, so 10 minus x squared will be less than or equal to 10, and at the same time it's greater than 0. So we have ln this part, we know it's somewhere between 0 and 10. So therefore the y value is this. When that equals 0, so we cannot do that because it's even slightly greater than 0, then that's okay. But this part, because it's less than or equal to 10, and when x equals 0, so this part is 10, which is still possible. So therefore the range will be from negative infinity to ln 10 inclusive. Right? So you get the idea. So this is, I think this is the most complicated situation in the AP calculus test. They ask you to find the range, or sometimes you would say you will need to get the range of this composite function. So that'll be all. It's a little bit complicated. You can review this and think about the function we had earlier, the log function and the quadratic function. Okay, thank you.